So good morning everybody, myself Acharya Vishvendra, and today I'll discuss a worksheet on physics formula list. So the first thing is here is moment of inertia. So it is mk square. M is the mass of the body and k is the radius of gyration of the body. This is definition of the moment of inertia. Next is angular momentum. So if a point mass is moving with a position vector r and at a certain instant position vector is r and velocity is v, so its angular momentum about a certain point is mr cross v. While in case of pure rotation motion, if a rigid body is rotating about an axis with an angular velocity omega, its angular momentum is I omega. Next is the net angular momentum of a body in combined translation and rotation. So suppose the rigid body is moving, so angular momentum will be due to the velocity of center of mass and due to rotation of the system about the center of mass. So it is the sum of the angular momentum due to translation and angular momentum due to rotation. So we have this complete expression. Here r is the position of the center of mass, so it's better to write it as rcm, and v is the velocity of center of mass. So this is how you can find the angular momentum of a system of particles. Next is kinetic energy in translation motion. So if a point mass is in pure translation motion, its kinetic energy is half ma square. Whereas if it is in pure rotation, the kinetic energy is half I omega square. I is the moment of inertia of the body and omega is its angular speed. So the net velocity, net kinetic energy is the sum of kinetic energy of center of mass plus rotational kinetic energy, which is half mv square plus half I omega square. Next is we have concept of torque. So torque of a point is r cross f, where r is the position vector and f is the point where force is applied. Then is a condition for maximum torque. So torque is maximum when the angle between position vector and force is 90. Let's elaborate this thing. Suppose this is a point O, and from here we draw position vector r at a certain point P, and there is a force F acting on it, and suppose that angle between r and F is theta over here. So torque is given by the cross product of r and F, and we know that r cross F can be simplified as rf sine theta into n cap, where n cap is a unit vector perpendicular to the plane of r and F. Then we can say that magnitude of torque is rf sine theta. So from here we can say that this magnitude is maximum when theta is 90, because sine is maximum at 90, and it is minimum at theta 0 or 180. So in both the cases torque will be 0. So that is how we can explain things in this way. So this is a basic level worksheet, and it's just to check your basic understanding of the topics you are working on. If you are able to work on 80 to 90, more than 80% problems, then you are working finely. But if you are unable to